Now, this is what we mean by an algebraic expression. It's x plus 2/5 the quantity squared. So the variable would be x squared. The expression would be x plus 5/2 squared, more than one term squared. So we have the variable expression squared. On the left, the constant on the right. So this guy's in good shape, don't really have to do anything more with him. Then take the square root of both sides. Don't forget the plus or minus. If I square root a square, you just end up with what's under the radical. This is really the square root of 7 over the square root of 25. Or that x equals, solve for x, you're going to subtract 2/5 plus or minus the square root of 7 over 5. Now in the next section you're going to see more things that look like that when we do the quadratic formula. Now I can't put the 2/5 and this together because the 2/5 doesn't have a radical 7. If it had a rad 7 I can bring it together, but it doesn't have a rad 7. Now, here's the variable squared right there. There's x squared. That means I need to first move the 5 over so that 3x squared equals 5. Again, there's the x squared, need it by itself. So I'm going to need to divide by 3 so that x squared equals 5/3. Then I take the square root of both sides. Don't forget the plus or minus. So that x squared equals plus or minus the square root of 5/3. There's nothing wrong. X equals. There's nothing wrong with the square root of 5/3. We can get that to a decimal approximation of 9 places. But your book doesn't like that answer. Because one of the things it says to do is to rationalize the denominator. So if I'm going to go your book's route, I'm going to have to take x, rewrite it as plus or minus the square root of 5 divided by the square root of 3. Since it's a square root, I just multiply it by itself. So that x equals plus or minus the square root of 15 over the square root of 9. Or x equals plus or minus the square root of 15 divided by 3. So this is what your book would have as an answer. There's no reason anymore to have to worry about that since our technology is so accurate. In the old days, BC, before calculators, and before these fast computers that we have today, in fact, my personal PC, and this guy is faster than the big computers used to be, does more work than the big computers. Used to take big computers a long time to do things. And when it did calculations, you'd have to concern yourself how many times it would have to do that calculation. How many additions and subtractions, how many multiplications and divisions, how many calculations it have to do in between. And it would be more concerning because in this particular instance, it would have to divide these two and then it would have to take the square root, and there would be a rounding with that division, there would be a rounding with the square root, and you build in too much error. Now, if I can, with a handheld calculator, get 8 places worth of accuracy, today's computers don't need to worry about this anymore. But there was a time it did. But then it made sense. Now it doesn't. Now it's just to torture you.